Have you ever had that feeling, that sudden cold prickle at the base of your neck that tells you something in the room has changed, even though you didn't hear a sound? You're driving down a familiar highway, the sun is hitting the dashboard just right, and for a split second, the car in the lane next to you doesn't move. Its wheels aren't spinning. It's sliding across the asphalt like a cardboard cutout on a string. Or maybe you're at home and you drop a spoon. You hear it hit the floor, that sharp metallic clink on tile, but when you look down, there's nothing there. You move the fridge, you check the corners, you scan every inch of the floor. It's gone. It hasn't just rolled away, it has seemingly vanished into the literal floorboards of reality. In the darker corners of the internet, we call these glitches in the matrix. We joke about living in a massive cosmic simulation, laughing off the existential dread with a meme or a viral clip. But behind the grainy phone footage and the panicked Reddit threads, there is something much more profound happening. Today, we aren't just looking at weird videos. We are going to uncover the physics of the impossible. We're going to look at why your brain lies to you, why light plays tricks on the horizon, and why, sometimes, the universe really does look like it's running on a broken graphics card. This isn't just a science lesson, it's the story of how we perceive existence and what happens when that perception breaks. To understand why the world glitches, we first have to talk about the most complex, beautiful, and deeply flawed hardware in the known universe. The human brain. You probably think you see the world in 4K resolution at 60 frames per second. You think you're a passive observer of the truth, but the reality is far more unsettling. Your brain is a world-class improviser. It is a storyteller that absolutely hates a vacuum. Right where your optic nerve attaches to your retina, there are no photoreceptors. This means you have a literal hole in your vision, a blind spot in both eyes at all times. But you don't see a black void in the center of your room, do you? No. Your brain looks at the patterns around that hole and photoshops in what it thinks should be there. Think about the weight of that for a second. Every single moment of your life, your brain is guessing part of your reality. When you see a glitch, a person who seems to disappear behind a thin lamppost and never come out the other side, it's often not the world breaking, it's your brain's fill tool failing. It's the moment the mask slips and you realize you aren't seeing the world as it is, you're seeing a highly curated, edited highlight reel. That realization feels lonely. It feels like standing on a stage when the lights go out and realizing there was never an audience. It's the first glitch, and it's happening inside your skull. But then, we have the glitches we can catch on film. Let's look at the floating helicopter. You've seen the video, a massive machine rising into the air while its blades remain perfectly still, like a toy being lifted by an invisible hand. When you see this, your gut reacts before your logic does. It looks wrong. It triggers a sense of uncanny valley. Because if the blades aren't spinning, it shouldn't be flying. Gravity should be screaming. But the science here isn't a simulation error. It's a beautiful, accidental symphony called the rolling shutter effect. Most modern cameras don't take a picture of the whole scene at once. They scan it, line by line, incredibly fast. If the speed of the helicopter blade's rotation perfectly matches the frame rate of the camera, the blade is in the exact same position every time the camera finishes a scan. It's a mathematical coincidence that creates a visual miracle. Yet, even when we know the math, the feeling remains. Our eyes don't work in frames, they see continuous motion. When we see a framed reality through a lens, our biological hardware clashes with our technological hardware. We are caught in the crossfire of two different ways of seeing, and the result is a glitch that haunts our logic. If the floating helicopter is a trick of the camera, what about the ships that fly? Sailors for centuries have reported seeing massive tankers hovering hundreds of feet above the horizon. This isn't a camera trick, it's witnessed by the naked eye, and it feels like a terrifying breach of physics. This is the Fata Morgana, perhaps the most poetic glitch in nature.
Normally, warm air stays near the ground and cold air sits above it, but sometimes the ocean chills the air directly above it while a layer of warm air sits on top, creating a temperature inversion. This acts like a giant lens made of air. Light doesn't always travel in a straight line. It's a traveler that takes the path of least resistance. When light hits that warm, cold boundary, it bends. The light from a distant ship is bent downward toward your eyes, but your brain, that stubborn storyteller, assumes light always travels in a straight line. So it traces the light back and places the ship in the sky. Imagine being a sailor 500 years ago seeing this. You don't have the physics of refraction, you only have the overwhelming heart-pounding fear that the world has ended. The glitch isn't in the sky, it's in the gap between how light moves and how we think it should move. But what if the glitch isn't just a trick of light or a camera setting? What if the very fabric of the universe is inherently glitchy? This brings us to the most famous experiment in the history of science, the Double-Slit Experiment. If you fire tiny particles of matter, electrons, at a screen with two slits, you'd expect them to pile up in two neat lines, but they don't. They create an interference pattern, like waves in a pond. They act like they are in two places at once. But here is the part that feels like a science fiction horror movie. If you place a detector by the slits to see which hole the electron actually goes through, the electron stops acting like a wave. It suddenly acts like a little ball of matter and forms two neat lines. The act of observing reality literally changes how reality behaves. It's as if the universe is saving on processing power, only rendering the exact mechanics of a particle when someone is looking at it. Scientists call this wave function collapse. To the rest of us, it feels like we've caught the simulation trying to cut corners. It suggests that at the most fundamental level, the universe isn't a collection of things, but a collection of possibilities that only become real when a conscious mind interacts with them. Then there are the glitches of the shadow people. Many people report seeing dark figures in their peripheral vision, only for them to vanish when they turn their heads. We often chalk this up to ghosts or exhaustion, but the truth might be even weirder. It might be a frequency. There is a specific sound frequency, 19 Hz, often called the ghost frequency. It's just below the threshold of human hearing, but it's the resonant frequency of the human eyeball. When your environment vibrates at 19 Hz, perhaps from a faulty fan or a distant engine, your eyes begin to vibrate microscopically. This vibration causes your peripheral vision to smear, creating the illusion of dark, moving shapes. You aren't seeing ghosts. Your eyes are literally glitching because of a sound you can't even hear. It's a reminder that we are biological machines, and like any machine, we can be hacked by the environment around us. We often talk about these moments as uncovered science, but the emotional truth is that they make us feel small. They remind us that our senses are a narrow window. We only see a tiny sliver of the electromagnetic spectrum. We only hear a fraction of the vibrations in the air. When we see a glitch, we are seeing the edges of our own limitations. We are like characters in a book who have caught a glimpse of the page numbers. Whether it's a camera's shutter speed, a temperature inversion in the atmosphere, or the strange behavior of a quantum particle, these glitches are the universe's way of telling us that there is so much more going on beneath the surface. As we move forward into a world of AI and deepfakes, the line between real and glitch will only get blurrier. We will have to rely more on the math and less on our eyes. But perhaps that's the beauty of science. It takes the spooky, the impossible, and the broken and finds the hidden logic underneath. The next time you see something that shouldn't exist, a bird frozen in the sky or a shadow that moves too fast, don't look away. That moment of confusion is the birth of curiosity. It's the universe inviting you to look closer, to dig deeper, and to uncover the science that holds the whole beautiful, glitchy mess together. Because in the end, the most amazing thing isn't that the world occasionally breaks, it's that most of the time, it actually works.